Today's video lesson will cover a few different topics, starting with a review of how to plot coordinate points, moving on to how to graph a table of values, then looking at if relations are linear or nonlinear, judging by their equation, their table of values, or their graph, and being able to create a table of values when given an equation. So we're going to start with just a review of the Cartesian plane and the different parts of the Cartesian plane. So the Cartesian plane is just a fancy word for this graph that has 4 different quadrants. So let's start by labeling the quadrants. The quadrants have specific numbers associated with them. So this one over here is known as quadrant 1. And then we go counterclockwise from there. Quadrant 2, quadrant 3, and quadrant 4. Now, as you can see in quadrant 1, actually I'll start over here. This line, this axis, we call it, this horizontal line, is known as the x-axis. It's where all of our x coordinates come from. And the vertical line that goes up and down, this is known as the y-axis. So when we're plotting points, we get one coordinate from our x-axis and one coordinate from our y-axis, and then we can plot it. So as you can see in quadrant 1 here, all of our x values are positive and all of our y values are positive. So in quadrant 1, we're always going to have 2 positive coordinates. Quadrant 2, we can see our x values are negative and our y's are positive. So our x value is always going to be negative and our y is always going to be positive. And when we have an ordered pair, like for example, maybe 3, 2, the first number in the ordered pair is always the x value, and the second number is always the y value. So here in quadrant 2, our x value, the first number, is always going to be negative, and our y value, or the second number, is always going to be positive. So in quadrant 3, we can see both our x and y values are going to be negative. And in quadrant 4, our x value is positive, but our y value going up and down from here down is negative. Okay, so here we have an example of an ordered pair, -1, 1. So we're at -1 on the x-axis going from left to right. So we start at 0, or the origin. So we start at 0, we go to -1 on the x-axis, and then we go up 1, +1, on the y-axis, and that's where we put our point. So this is known as an ordered pair. Okay, so that's just to kind of familiarize you or reacquaint you with some of the vocabulary associated with a Cartesian plane and graphing. So next we're going to look at a little bit more. We're going to practice how to plot an ordered pair on a Cartesian plane. So each ordered pair, like I'd said, is made up of 2 coordinates, an x coordinate and a y coordinate, and they go in the following order. The x comes first and then the y. So in order to plot a point, we have to move from the origin, which is this 0, 0 point right in the center. From the origin, first we're going to move left or right on the x-axis. If our x value is positive, we'll move to the right. If our x value is negative, we'll move to the left, because this is really just like a number line. And I won't number all of them, but 1, 2, 3, 4. You get an idea. And then going this way, we would have -1, -2, -3, -4, and so on. So to plot a point, we start at the origin, and first for our x-coordinate, we move left or right, depending on if that number is positive or negative. And then we move up or down, depending on whether our y value is positive or negative. If it's a positive number, we'll move up. And if it's a negative number, we'll move down. So let's take a look at some examples here. I'm going to label some of my y-axis as well. So these are positive numbers, 1, 2, 3, 4. And then we have going down, -1, -2, -3, -4, and so on. So I'm going to change colors here. We'll do green. So my first coordinate is 5, 7. So starting in the center at the origin, I'm going to move 5 along my x-axis. So 5 on my x-axis would be right here, okay? But then I need to go 7 on my y-axis. So 7 on my y-axis is 1, 2, 3, 4, 5, 6, 7 here. So it's where these two lines intersect. So if I were to kind of go across and up, that's where the two lines intersect. So that would be my point A on the graph. So I've gone over 5 on my x-axis, and then I've gone up 7 because it's a positive 7, so I move up. So that's A. Okay, so point B, again, we have an x, we have a y. Point B, I'm going to go -3 on my x-axis, which is 3 to the left. And then I'm going to go +4 on my y, which is up 4. 1, 2, 3, 4. You can see that it matches where the 4 is. So that would be my point for point B. Point C, x and y. Point C is +2 on the x-axis, so that's moving left to right. So here's +2 on my x-axis, and I'm going to go -5 on my y. So going up and down, -5 means I'm going to go down 5. I'm going to go all the way down to where the -5 is along my y-axis. So that would be point C. And finally, I have -4 on my x, which is over here, and then -3 on my y, which is down here. So here would be my final point, D. So I have 1 point in each quadrant. You can see the A, both values are positive. For B, which is in quadrant 2, the x value is negative, but the y value is positive. D, both values, x and y, are both negative in that quadrant. And then in C, we have x values that are positive and y values that are negative. So now we're going to take a look at how to plot points from a table of values. So we've seen how to plot points that are ordered pairs. A table of values is just a table that shows you several ordered pairs that fall on a common graph. So here we have a list of x values and a list of y values, and they go together. So this x value goes with this y value, and this would be an ordered pair on the graph. This x value goes with this y value. And all of these points together will form a graph. They have some kind of a relationship that they're all part of the same common graph. So let's plot these. So x, I've got -2 and y 2. So my ordered pair is -2, 2. So starting here, I should maybe label some of these. I'm going to count by 2s. 2, 4, 6. I think that's as high as we go. And then I'll go -2, -4, oops, here, -6. And then going up on my y, I've got 2, 4, 6. Going down, I've got -2, -4, -6. And it's always a good idea to label your x and y axis. There's y, here's x. So my first point, -2, 2. So -2 on my x and +2 on my y. There's my first point. Okay, next I have -1, 3. So I go -1 on my x, and I go 3 on my y, so that's there. 0, 4. So on my x-axis, 0 is right here at the origin. Okay, so we're looking at this like just a single number line. We have -2, -1, 0, 1, 2. So right here is 0, but then I'm going to go up 4. So my dot's going to be right on my y-axis. Then I have 1 and 5. So 1 on my x, all the way up to 5 on my y. And then I have 2, 6. So you can see that this makes a straight line graph. So I can connect those because they're all part of the same graph. And I could assume that this information, if I were to continue to add x values that go beyond 2 or kind of go backwards from -2, I could assume that this graph is going to continue in that same pattern. Okay, so it would be a straight line that would continue on. So you could actually extrapolate data and figure out, if x were 4, what would y be? Or if x were 3, what would y be? If x were 3, we could guess that y is going to be 7. Okay, because it's going to continue in the same pattern of over 1 and up 1. Okay, so now let's do the green one here. So we have -5, 6, -5 and 6 right here, -4 and 4, -3 and 2, -2 and 0. So I'm not moving up or down on the y-axis. I'm just staying right on the x-axis. And then -1 and -2. Okay, so this line is a little bit steeper, but again, it makes a straight line. And we could extrapolate some data on this as well. We could assume that, outside of this, if I wanted to continue my table of values backwards and I wanted to say x is -6, okay, so if x is -6, we know that for every 1 that we move back, we have to move up 2 on the y-axis. So that would be our next point, -6 and 7, 8. -6 and 8. So we could figure out more points on this graph just based on the pattern that's developing. Okay, now since both of these graphs make straight lines, we know that these are linear relationships. So if a graph makes a straight line, we know it's a linear relationship. It means that for every value that x increases, y is going to increase at a proportional value. So if x goes up by 1 and y goes up by 1, that's going to continue. Or if x goes up by 1 for every 2 that y increases, that's going to be a pattern that continues. So let's look at a few more ways to tell if graphs are linear. So one way, of course, is to draw a graph like we just saw. In a graph, if a relationship is linear, it makes a straight line. So that's what we just looked at. So you could always look at your table of values, graph it, and see if it makes a straight line. But sometimes that's a lot of work, and you don't want to graph a whole table of values just to see if it's linear. But we can also just look at a table of values and tell if it is linear or not. So in table of values, if the x value and the y value both increase at a consistent rate, then we know it's linear. So in this table, x is increasing by 1 every time. Y is increasing by decreasing, I should say, by 2 every time, -2. Because these are consistent, if we were to go to graph this, say I had a point, and x increases by 1, y goes down by 2. X increases by 1, y goes down by 2. It's going to form a straight line because we are moving in a very consistent pattern. For every movement that x makes, y makes a similar movement that stays consistent. In this one over here, x is increasing consistently by 2 every time, but y is not increasing consistently. First, it increases by 6, and then by 12, and then by 20. So if we were to graph this, we would see that it is not linear. It doesn't go in a straight line because for every 2 that x increases, y is increasing at different rates. So that's how you can tell in a table of values, is look at the difference between the x values and the difference between the y, and they would have to be consistent on both sides. So finally, we can tell just from an equation if a relationship is linear. If an equation has a degree of 1, then it is considered linear. It means there's no exponent higher than 1 in an equation. So this equation here, y equals 3x plus 2, is linear because there are no exponents greater than 1. But if we had an equation like this, y equals x squared plus 2, then we know that the relationship is not linear because this has a degree of 2. Okay, so those are 3 ways to tell if an equation is linear, or sorry, if a relationship is linear or not. Looking at the graph, you can just look at the table of values, or you can just look at the equation and see what the degree is. So finally, we're going to look at how do we create a table of values from an equation. So we can take an equation and we can actually pull ordered pairs from it, and then we can graph it onto a graph. So the way that we do that is we substitute chosen values of x into the equation and solve for y. So we can just pick any random numbers for x, anything we want at all, and we can put those into the equation and we can figure out what y would be. So in this one here, if I say x is 0, I could determine what y would be in that case. So when x is 0, I'm going to put in a 0 for my x. When x is 0, I'll solve this. 0 take away 8 is negative 8. So when x is 0, y equals negative 8. Okay, and so I was able to figure that out just by substituting that number for x into the equation wherever there's an x, and then I just solve for y. And again, I'm just picking any random numbers. You could pick any numbers here for x, and you could find out what its corresponding value would be for y. So let's continue that. Let's try the rest here. If x were 1, this would be 1 minus 8. 1 minus 8 would be negative 7. Okay, so when x is 1, y is negative 7. Okay, when x is 2, okay, then I'm going to have 2 minus 8. 2 minus 8 would leave me with negative 6. And you can see there's a bit of a pattern developing here. For every 1 that x is increasing, y is also increasing by 1. Okay, so we can see that this is looking like it is a linear relationship, because for every 1 that x increases, y also increases by 1, and that seems to be consistent. So we could actually, instead of substituting in the rest of these, we could probably extrapolate this data, and we could say, well, I'm going to assume since x is increasing by 1, y is also going to increase by 1. So this would be negative 5, and this would be negative 4. And we could check those out. Let's put in, instead of x, we're going to put a 3. 3 minus 8 is in fact negative 5. And 4 minus 8 is in fact negative 4. Okay, so now that we've taken that equation, we've chosen some random values for x, we've substituted them into the equation, and then we've solved for y. Now we have 5 ordered pairs here that we could actually graph. So we could put these on a graph and we could see what this looks like. And we know that it's going to be a straight line because for 1, my x and y are both increasing at a consistent rate. And for 2, my equation doesn't have any exponents greater than 1. So we know from those 2 pieces of information that we looked at back on this slide that this would be a linear relationship. So let's take a look at Next one. So again, I've just chosen some random values for x, and we're going to substitute those in to see what our value for y would be. So 8x minus 4, instead of an x, I'm going to put in a 0. Okay, I'm going to use my order of operations. So I'll do multiplication first. 8 times 0 is 0. I take away 4 stays. And I get 0 minus 4, which is negative 4. Okay, so I'm going to change, let's erase this whole thing. Now we're going to try the next point. So when x is 1, so I'm going to insert a 1 into this equation, or substitute in a 1, and see what that gives me for a y value. 8 times 1 is 8. 8 minus 4 is 4. Okay, so let's try our next one. So my next value is 2. Oops. So I'm going to say 8 and put in a 2 for my x. 8 times 2 is 16. And 16 minus 4 is 12. Okay, so we can see a pattern developing here. For every 1 that x is increasing, y seems to be increasing by 8. So from negative 4 to 4, we had to add 8. And then 4 plus 8 gives me 12. So we can see that it looks like this is a consistent increase. And that would make sense because this equation doesn't have an exponent greater than 2. So we know it is linear. And if it's linear, that means both the x and the y value have to increase at a consistent rate. So if x is going up by 1 every time, y needs to go up by a common number every time as well. And in this case, that number is 8. So we could actually figure out what the next 2 points are, because x is still going up by 1 in each of these points. 12 plus 8 would be, whoops, let's try that again. 12 plus 8 would be 20. And then 20 plus 8 would be 28. And of course, if you wanted just to check that, you could substitute it in and check. But when x is 3, we're going to see 8 times 3, 24 minus 4 is 20. So it does work out. So this is, again, a linear relationship because the x and the y value are increasing at a steady, consistent rate, and because the equation does not have a degree higher than 1. And if we were to graph this, we would see it would make a straight line.